So this is what I think is important here, all right? You have to publish paper that having the QOQ factor. And all these Q, O, and Q, they are equally important to me. Okay? So since this is a workshop, it's not a lecture, right? So you don't have to agree with me. Okay? And we will open this for discussion and questions. So just feel free to interrupt me if you think that I'm wrong or you think that you have something else to say. Right? So this is what I think is correct, QOQ. So what is the first Q? Quality. Quality means the data you publish, it has to be convincing. Okay? So in order for you to produce convincing data, you have to be able to design your experiments, or if you're doing theory, your calculation very carefully. Okay? And you have to give people the full explanation and the full view of your research and your finding, okay? With full justification and evidence. It sounds common sense, but a lot of paper, if you read, you will have doubt with some result. You say, why they don't provide this data to prove this? So which means this paper is still not complete. Alright? So quality means people cannot argue with you with your result. They have to agree with you. Okay? So this is one important factor. The second is originality. Yes. Yeah, at the beginning I told you already, peer recognition. If you are doing research, which means other people who are doing research in your field, they recognize you. They say, exactly. So the question is asking about what is peer recognition. I think I told you already. So, which means people who are running the same research in your field, they know about you. When they look at your name, they say, I know this guy published this paper, I worked on this before. This is what we call peer recognition. Okay? But of course, peer recognition has many levels. General level, people know you are in the field, at least. Peer recognition, higher one means people know that you're one of the best in the world. That is also peer recognition, okay? All right, let me jump to the second point, what we call originality, okay? So you just don't publish paper that repeating someone else has been done before, all right? You have to do something new, okay? So I just put a simple phrases here, try something new. And one of the good way to do it is that, because there can be 101 way, 101 new thing. For example, how to boil eggs. Boil eggs, okay? Whether you want to fry it, deep fry it, boil it, or whatever you cook in Milo, coffee, or whatever. But is that important? Okay? So you have to identify what's are important and yet not being well studied. And this originality will pop up because it has value. It has impact to the field. So I believe this is also very important. Quantity. So if you think that you publish a good paper with high originality, just one paper, you use it in here, and I start doing research with Professor and also Professor until my master's degree, and then I moved to Japan for my PhD at Osaka University. And then I was recruited to become a professor in the United States. So things does not come automatically. You have to perform in order to earn this recognition. Okay? So I will tell you some of my old results or old history or old examples and slowly bring it back to what I have been doing in the past 2 years in Mission Tech. Okay? So I'll give you all kinds of examples. I hope one of them will quite similar to what you are having in experience. And of course, can I expect some of you are not from engineering and science? How many are not from science and engineering? Not from. So are you from management? Something else? Okay. So unfortunately, I don't have example in management. So maybe you can tell me after you listen to mine. Tell me what you think is analog to my examples. Okay? Let's do it. Let me give you one first example. The first project that I performed in Japan. This is on blood crystals, right? And this is about this beautiful crystal. And this is actually a single crystal. Okay? It's called CLBO is a little complicated, but that's okay. Just call it CLBO. This is not a normal crystal. Crystal means it's a materials that if your eyes can look into atomic level, you can see that the atoms are arranged in a regular pattern. Okay? In a regular pattern, you can repeat the same pattern everywhere and you move around in the same crystal, in the same direction. This is crystal. A good example. Anyone has a diamond ring? No? No ladies, not many ladies here got married who own a diamond ring? Not yet? Okay. If you have one diamond ring, okay, diamond is a crystal. Okay? And anyone has sapphire, looks red or blue, not the one from Masamaran. Okay? So crystal means including some gemstone. Okay, this is the best example. Silicon. Anyone thought of silicon? All you know silicon, right? It's one of the crystal. Okay? But this crystal has the property for optics, for laser applications. Okay? It's a magic stone. Why? Because, for example, if you shine a laser light in close to infrared, about 1 micrometer in wavelength, into the crystal in the right direction, you found that the laser will change the green color. Sounds amazing. So you're changing the color of the laser by crystal. And not only that, which means the technical term is that this is the so-called non-linear optical crystal which can convert the wavelength of laser. And why is this so important here? Because shorter wavelength, you find more applications. I will show you some examples here. Alright, and actually this is the so-called devices that we develop from a single crystal. From a single crystal, once you identify which direction is good for your applications, you cut them to the direction that you want in the size that you want. Okay? And this is actually developed in Japan, Osaka. It looks very complicated, but it's just one unit cell. Crystal means this unit cell can repeat itself in infinite atomic scale distance. Okay? So just ignore about this one. They simply tell you that this is very complicated and there are many others new crystals has been discovered so far. Okay? But this one called CLBO at the bottom here, which I was studying about this, is the best. Okay? It's the best for some aspect. For the so-called ultraviolet laser generation. Okay? And this is how it looks like.